Raven Lining Systems, an industry leader in the protection and rehabilitation of wastewater and potable water infrastructure for almost 3 decades, is proud to present a 2-part demonstration series on the proper protection and rehabilitation of concrete manholes and other wastewater infrastructure. Please enjoy the demonstration.
Welcome to Rehab Zone at UCT. Those of you that got to see the presentations this morning, this will basically be a hands-on version of what they talked about in their slides. We'll talk a little bit today about, not about can and can't. Can I do this? Can I do that? Can I do it this way? Can I do it that way? We'll talk about what we should and shouldn't do for long-term performance. And there is a difference. All coatings, no matter what we end up with down there, what we'll talk about why we chose what we chose, have industry standard prep standards, which is what usually ends up being the failure mode for a product. Not always. I've heard before, all products will work if the prep is done right. Kind of true, but not exactly. There is wrong choices for certain situations, but you can take a great product and ruin it by not doing this. What you have here is a brand new precast structure that, if you can see from the outside edge, looks like a pretty good precast structure and may be looked at and thought, let's just clean that and spray right over it. But that's not the SSP and NACE standard when it says sound concrete. This on top is not sound. We can show that by looking inside. This has been prepped. This side is what we would do for precast concrete. Some coatings, most coatings will tell you, like talked about, get to a certain profile to accept the coating that you're looking for. When you blast this to get to that profile, you see how this has been opened up, all these voids. You're looking for free of holidays and free of voids. All this did was expose them. You have a weak area on top that you got rid of. This side over here, all we did was keep going for a while just to simulate corrosion in a rehab. What you might see, much more aggressive profiling, something that really needs to be taken care of beyond new concrete. We're going to jump over to the other side. We treated this piece like new construction. This is what was underneath. We chose a polymer modified cement that can be skim coated to take all of those imperfections out and give that coating a sound, solid substrate to adhere to 100%. If you would have coated over this, all the voids in the back would have represented an area where you weren't getting solid. You were adhering to the outside, but just underneath there's nothing. So you've got nothing. The beauty of Polymer Modified is when a coating manufacturer has a spec that's calling for a specific cleanliness and a specific profile, he's talking about the product that coating is actually touching. So you're actually going to be following a prep spec twice when you do this. Once to get to here, and then another one to apply the coating. With a Polymer Modified, it has a recoat window similar like a top coat would have. This particular one has 14 days. You have 14 days to reapply without doing anything but maybe a light clean. But to get that product to this point, any coating needs to get to these points. Cement is about the cheapest way to get a rehabilitation structurally and effectively to the point at which you need to coat the structure. We're going to go ahead and move over to the coating process. This particular product used today is 100% solids, high build epoxy coating. The reason it was picked, a manhole is an underground concrete structure. It's impossible to fully dry that out on a everyday, every hole basis. You need a product that is moisture tolerant and can adhere in those environments. Epoxies do that best. They fit the monolithic profile that we were looking for in our presentations, no seams, no voids, and they adhere where you need them to go. There are other choices that are not epoxies, but you have extra hoops to jump through to get there. They're not moisture tolerant, so you have to do something to completely dry out a manhole that's underwater. So 100% solids epoxy was what was chosen for this particular, because it is you have the highest percentage of getting the end result that you're looking for. One of the most common things that kept coming over and over in the presentations earlier was about post-coating testing and testing during the coating process, different types. These are industry standards that where a coating can prove that it's doing the job that it says it was going to do. It needs to adhere to the wall, it needs to be a certain thickness, and it needs to be in the environment that you've designed it for. There should be no coating or coating process that says we don't need to do that. Ours is different, ours does something different, ours can't do that or can do that. These are industry standards. How do you, as an end customer, know that you got what you just paid for? Unless you can verify that it is the thickness that you're paying for and it is adhered well and can do the job that it was designed for. So during this process, he will be checking film thickness. 100% solids means that when it dries, it's the same thickness as it was when you put it on. Wet and dry film. So you can check it while it's wet. It'll dry, it'll be the same thickness. If you'll notice how he's spraying that, he's going up, down, left, right, angled. That's called cross hatching. It causes you to get a much more consistent mill rate on the wall. I get asked, is the structure as strong when you're done as it was when you started, when it's got heavy deterioration? Just think about, let's call it 3,500 PSI when it was built, and you rehabilitate it with something 10,000. Half-inch of cement, and then put an 18,000 compressive epoxy on top of it. That's a stronger structure when you're done than the day it was built. There are other technologies, polyureas, polyurethanes, that have extremely quick drying and in-service times. But generally speaking, or just about always, they're not moisture tolerant. You have to jump through extra hoops, especially on a day like today when it's raining. And as fast as they cure, they don't wet out the surface as well. That's why their adhesion suffers compared to an epoxy coating. For this particular application, we would have recommended 125 mils on this product. He just got 127 on there, multiple checkpoints. That would be what the finished product would look like. That's basically it for the outside portion of this. We're gonna move this whole thing inside. We have another one of these that we sprayed previous. We're gonna do some adhesion and holiday testing inside.